So before I show you an example, we need to talk about this. It's really important. I'm going to ask you 2 questions. We'll do 2 examples of this. Example 1. Put the angles in order and the order will be smallest to largest. Here's a triangle, we'll call it ABC. And then your sides across from those angles are lowercase a, lowercase b, and lowercase c. Let's say this is the given information. Side A is 10, side B is 6, and side C is 17. Put the angles in order based on that information. Yeah?
BAC?
BAC is correct. Can you explain why?
So like, if you wanted to make something smaller at the end, you'd have to tighten it, right?
Yeah.
So like, if I were to tighten my fingers,
Yes.
the distance between on my hand would be smaller. But if you're here, Birdie, watch. But if you were to make the fingers go out more, right? They're covering more area.
Yeah,
You feel me?
now your hands are opened up for
Exactly. Exactly.
Exactly. To sum that up, basically, the smallest angle is across from the shortest side, and the largest angle is across from the longest side, and it's that concept exactly. If it's narrower, then there's going to be less distance across from it, essentially. Now, a very straightforward way to do this without overcomplicating it is you could just put the sides in order first. 6, 10, 17, smallest to largest. Then you put their letters underneath that. So that would be sides B, A, and C, which correspond with their angles as well. So angle B, angle A, angle C. That's the order, smallest to largest.
Chopsticks, you want to grab it? Yeah.
Thank you for that demonstration. I appreciate it. So that's the concept you need to be aware of. I'm going to give a more straightforward example, what you are going to be using specifically in this class. Which angle is bigger? This will have a new picture. A or C? I'll have this set up in the same orientation, just with new numbers. Let's say that angle A is 32 degrees. Side C is 17, and side A is 13. Yeah? Yeah, can you explain why?
Because this 17 cross 13 is bigger than 13.
Exactly. So,
If you have chopsticks.
since 17 is bigger than 13, those corresponding angles are going to have the same size proportionally. 17 corresponds with C, that angle. Even though we don't know the number, we know that it's going to be bigger than 32. That concept is what you need to be aware of and pay attention to make these problems easier for yourself. So I'll write out an explanation for those who need it. 17 is greater than 13. If we correspond that with their sides, that means C is greater than A, side C is greater than side A, therefore the angles, same thing. Angle C is greater than angle A. Angle C is bigger. If you can figure that out, you're going to make your life easier. That's what I want you to be able to do. All right, let's do an actual example. I'm going to start off with an easier case. These problems can come out one of three ways. So we're going to have 3 examples total. We'll get through 1, maybe 2 today. We'll see. First example. Solve the triangle. So find all missing parts. Our givens. We are given measure of angle B is 15 degrees. A is 4.5 and B is 6.8. So when I draw this first triangle, take up half the space tops. You're going to need it the other half for a possible second triangle. I'm going to draw this the way I usually do. Triangle ABC. Sides ABC. And then we'll label the givens. We are given that angle B is 15 degrees. Side A is 4.5. And side B is 6.8. Now last week when we talked, I said it was really important that you label the orientation, the arrangement of the angles and sides from the get-go so you know how to approach the problem. Angle, side, side. It's not the angle sandwiched between the 2 sides. It's not those 2 sides. So it's the next 2 if you just keep going around, if you will. This is angle, side, side. Meaning there could be 2 triangles. Could be is not a guarantee. You could have 1, you could have 2. Or, the third case, you could have none. So it depends on the numbers, depends on the problem. So it never hurts to preemptively plan for a second triangle. That way you don't forget to do a second triangle. So we'll call this triangle number 1. Now I'm not going to draw it yet, but I'm going to create the space for triangle number 2 in case it exists. And that would be over here. So I'm just going to label it for now, triangle number 2. If I need it later, I have the space to draw it. If I don't need it, then no harm, no foul, but I've at least prepared myself for that possibility. We have to do a little bit of work to be able to figure out if we have a triangle number 2. So, with our given information, we're given both B's and then A, side A. So, what are we going to find first in the triangle? If you remember Thursday's notes, law of sines.
A.
Yes, angle A. Because we have the B's, we have both of them, and then we have one of the other sides. So we can use law of sines to get this started. So first, let's find angle A. And we'll use law of sines. We're given the B's, so we're going to use the B's, of course. And then we want to find A, so we're going to use the A's. Sine of A over A. If you happen to miss Thursday, I'd go back and watch that video later because this is going to be pretty confusing. And I'm just noting given above because anytime I set up law of sines, I always use the given numbers. It makes my life easier, even when I have a choice to do something else. All right, we have sine of our B is 15 degrees. Over little b, side B is 6.8. Equals sine of A We don't have that yet. And then little a was 4.5. This may look the same as what we did on Thursday, but it's not. So we will cross multiply, that will still be the same. But the algebra from there is going to take a turn. I'm going to write my result over there. Crossing left, we have 4.5 sine of 15 is equal to 6.8 sine of A. And if it helps, put a times before you put the sine of A, just to reiterate that we will divide to get the sine of A by itself. So next, I need to divide by 6.8 on both sides. Do not use the calculator yet, no rounding, none of that. So next we have sine of A is equal to that fraction. Don't use the calculator yet, still not there.
You have to second sign it?
Yes. So I'm going to write out the algebra just this once for anyone who wants to see it, if it'll help your understanding, but you don't have to do this if this is not something you're comfortable with. So I'm going to write this again to show the steps. What we're going to do is we're going to take inverse sine of both sides to get that A by itself. That's sine with the -1. So I do that to both sides and just drop both sides down into those parentheses. So then when sine and its own inverse are present together, they're going to cancel each other out, and we just have the A left over on the right side. And then I'm going to go ahead and jump into the calculator for the next step, so I'll go ahead and round. So this is just A, and then this whole thing you have to type into your calculator. That's why we're waiting till the end to use the calculator.
What do we round to?
Thank you for asking. So last time I know we did hundredths, but I checked the test after that, and the test is all in tenths, so I figured just for that reason we'll go tenths. So type all that in, make sure you're in degrees, and use that fraction button if your calculator allows. Hold on, before I do that, let me put an inverse sine. That's second sine. Now we'll type all that in. 4.5 regular sine of 15 over 6.8, all in parentheses. 9.9. That is the value of A. Angle A, 9.9. Questions on the algebra solving for A? Yes. Because it's not directly with another sign of something. That's with a sign embedded into a whole fraction. It's different that way. And if I can give you a visual, that might help even more. It's inverse sine of A. So like that function, I can't, from a grouping perspective maybe? Like they directly cancel each other out, leaving just the A on the inside. Yeah. All right, so we got 9.9 for angle A. So if we were to make a second triangle, it would be because A could potentially be obtuse, and our calculator didn't give us obtuse because inverse sine can't. But if we look here, first off, I didn't need to find A to make that determination, but finding it just further emphasizes whether or not we have a second triangle. there is no way that this A could be obtuse because it has to be smaller than B. So, in that case, there is no second triangle, and we just have to solve this one. So, when that happens, I just want you to put no second triangle.
Wait, how do you know that there's no second triangle?
Because of that angle side relationship we talked about.
Yeah.
If we take out the green for a moment, side B is bigger than side A. So angle B must also be bigger than angle A. If angle A is obtuse, then it'd be bigger than B. I can show you the what would go wrong if you assumed there was a second triangle. I could do that if that helps. What would also help is if you saw an example that did have two triangles, but that is going to take me
I thought obtuse meant it was like 90 degrees or bigger.
over 90, yeah.
It's 9, that's smaller than 90.
Right. Okay, so what the second triangle proposes is that there is an alternative answer. They're both correct, but it won't give us the obtuse angle. So it's this A that is up for debate. Since we have to use inverse sine to solve for A, and as that's what we discussed for like the first 10 minutes about how inverse sine is a flawed method, because we have to use that. A may not always be an accurate answer depending on the triangle you're given. So let's say we assumed that there was a second triangle. I'm going to set this up, but I'm intentionally making A obtuse, and you can even draw it obtuse if that further sells the picture for you. So we have A, B, C. And then I'm going to fill in the original information just like I did before. But I'm going to do it in pink to color code with triangle 2. So this is what we have. And we're saying that there could be a second triangle where A is not acute, it's actually obtuse. So how we would get that I'm grabbing the wrong pen over here. This is what I want. What you do is you take the angle A you just found and you take it from 180 degrees to get the other version of A. 180 minus, and then we got 9.9 degrees. And I think that's 170.1. Yeah. There you go. You're already pointing out the problem with it. So if I get 170.1 degrees, it's impossible for this to be an obtuse angle because, as Devin just mentioned, if I add 170.1 and 15, lest you don't believe me, I'm already over 180. And remember, the whole triangle cannot exceed 180. So that's why there is no second triangle on this problem.
Isn't angle C obtuse though?
Can't be. Wait, oh, you're talking about the original. Yes, yes.
Angle C is definitely.
Exactly, exactly. That's just another reason why it won't work. So, since that is not allowed, too big, we say no second triangle.
Or we can just solve angle C.
Right, and then we just solve the original triangle and then it's all said and done with. And you don't have to write out the full words, but just that will suffice. Now, you're not done. You have to still finish the first triangle. That's why these problems are so tedious and lengthy to complete, especially when there is a second triangle. Now you have to solve two and not just one. So, let me quickly finish the triangle I started, and then we'll be done with the problem. So we still need to find both C values. Now, thankfully, finding angle C won't take long because we already know two of the three angles, so that's going to be a simple calculation. angle C. We have 180 minus our two angles that we did find, 15 degrees, that was given, minus 9.9 degrees. $155.1. So that's the measure of angle C. And we have to find side C now. To find side C, we'll use the law of sines. Reminder, there's no Pythagorean theorem here, so we have to use the law of sines. Again, for law of sines, I'm going to use the A's, or sorry, not the A's, the B's, because that's what was given. We are given both B values. So we have sine of B over B, which is what I used earlier. And this time, I'm going to find the C's. So I need sine of C over C. Filling that in, I have sine of B is 15, angle B, over side B is 6.8, is equal to sine of 155.1 for angle C, over little c is what we're looking for. And then I am just out of space, but I can fit this on a Post-it note, so do that. Now I'm going to kind of cheat here. Looking at your guys' homework, you guys are clearly able to follow the cross multiplying and deduce what would happen very quickly. So I'm just going to skip to the final setup of the answer. So the shortcut, just looking at it, the side that doesn't have the missing letter, so that would be 6.8 times sine of 155.1. Those are going to be multiplied on the top of the fraction. 6.8 sine of 155.1. And then the extra sine function that is paired with the c, it's going to get divided on bottom. So if I cross multiply and do the algebra, that's what I'm going to end up with. I'm skipping that work. If you need to write it out to convince yourself this is correct, then do that. And then we'll use our calculator and round to the nearest tenth to get our answer for C.
We don't have to do this again?
No, not on that one. We don't need to do inverse sine on this one because C is by itself. It doesn't have a sign attached to it. So that's why this is nicer. So 6.8 sine of 155.1 over sine of 15. Round that, we get 11.1. C is 11.1. And when you're done, your triangle should look like that. The three missing parts all filled in.
So we don't have to write out like